Welcome back, Math Marvels. This is Math Mini Lessons, and my name is Sarah, and this is day 2 of the 7th grade math review exam, which is happening right after break here in New York. So if you have your copy of the exam, make sure you're going through it on your own, trying it out, and try and find the problems that were challenging, things that you were not quite sure about, so we can, when you go through this with me, you can find where you can make adjustments, where you need to make some reviews, and you can make some changes in your answers. And also engage with us in the comments if there are questions or topics that you want to see us cover. So with that said, you can see here we have multiple choice starting off in the beginning for the first set, starting from 33 to 38. And just like in the last video, I'm going to do 4 at a time and just give you the answers first. And then if you have them correct, you move on to the next section. If not, you can just go to the exact questions you need. And starting in 39, you have 1-point questions. And so I'll go through all the 1-point and share what the correct answer is, as well as a strategy, a sound strategy. Now, if there are other sound strategies, that's always possible, but I'll try and be as quick and precise as possible without making this video too long. So I hope you find this really helpful. With that, we're going to jump right into multiple choice. See you soon, Math Marbles.
And in day 2, we have some multiple choice, and we're going to have some 1, 2, and 3-point problems. So we're going to jump right in. We'll do the first 3 multiple choice together and then jump into the constructed response. All right, so for the first ones, for number 33, this is an RP problem. The answer is D. For number 34, it's a stats problem. Or actually, it's a probability problem. The answer is A. For 35, it's an EE problem, and the answer is A. I'll put it on all of them. For 36, it's a number sense problem. The answer is B. And for 37, it is an EE problem, and the answer is A. And the last multiple choice problem, 38, is an RP problem, and the answer is B. Okay, so we're going to do all the multiple choice. So let's start with the first one, 33. A bicyclist travels 6.5 miles in 2/3 hours. What is the average speed in miles per hour? So we want miles per hour. So we know we have 6.5 miles in 2/3 hours. We have a complex fraction to work through. So let's rewrite it. So 6.5 divided by 2/3, which is the same as 6.5 times 3/2. And I'm going to change this to an improper fraction so we can do it. 2 times 6 is 12 plus 1 is 13. So 13/2 times 3 over 2 is 39/4. You're not going to see that as any of the choices, so you do have to divide it one more time, change it back to an improper fraction. 4 goes into 39 9 times, with a remainder of 3. So that is his rate, which is D, 9 3/4, which represents the miles per hour. Let's go to 34, and I love these types of problems. These are combination problems, or combinatorics was a term I heard when I was little. And I want to know what is the probability for this deli customer. You have 2 different types of bread, you have 2 different types of meat, and you have 3 different types of cheeses. So 2 breads, 2 meats, and 3 cheeses. So how many different kinds of sandwiches can you make with this combination if you pick any of the breads, any meat, and any cheese? Well, 2 times 2 is 4. 4 times 3 is 12. So there are 12 combos possible. That's why I love this math, because I used to try and figure out how many outfits can I make. Like if I had 3 jeans, I have 5 different sneakers, and 4 shirts. I could just multiply all those together to figure out how many different combinations I can make. I can make 15 times 4, I can make 60. So those are all the combinations. But the question is asking, what is the likelihood of getting white bread, turkey, and Swiss, this kind of sandwich? So let's think it through. For the white bread, it is 1 out of 2. That's just for white bread. For turkey, it's also 1 out of 2. That's a chance of turkey. And for Swiss cheese is 1 out of 3. So you have one chance, 1 times 1 times 1 is 1, out of 12 different combinations, or 1/12. Love probability problems with combinations. These are actually a lot of fun, and it's pretty just helpful to know. All right, so there you go. So you can pause, jot this down. And again, each of these just represents the fraction. I have one piece of white bread out of all types of bread, one type of turkey out of all types of meat, and one Swiss cheese out of all 3 types of cheeses. Let's move down to number 35. Frank is riding a taxi to get to work. The cost of riding a taxi includes a one-time fee of $2.75, so that's our constant, and $2.60 per mile. So here's our rate, and here's our constant. Like, no matter what, he has to start by paying that $2.75. If Frank rides for 4 miles and pays a $2 tip, how much will be left over if he pays with a $20 bill? Ooh, this one got spicy, spicy, spicy. All right, so I'm going to start by writing out my equation. So $2.75 is when he gets in, plus $2.60x. And then he also pays $2 per tip. Okay, this is cost per mile. That's our rate, and that's our initial charge. Like, no matter what, he's gonna have to pay that. Okay, like, so we know he's gonna go 4 miles. So I'm gonna just do 260 times 4. So that's $10.20. So $2.75 plus $10, 40 cents plus $2. So we're just going to add all of those together. 2.75 plus $10.40 plus $2. And that's $15.15. So if he pays with a $20 bill, so 20 minus $15.15 is going to give us $4.85. And there you have it. That's it for 35. So it was a mix of, can we do some work with rates? And so it's definitely EE, but then also figure out the change at the end. So some number sets in there. 36. The sum of 2 numbers is 0. Ooh, so we're going to have 0 pairs. And that means these numbers are going to be opposites. So if one of the numbers is 5, what is the other number? So think about this. 5 plus what number is going to give us 0? 5 plus minus 5 is equal to 0. So it's opposite. And that's why it's B. All right, that makes sense. So if I have $5, I owe you $5, and now I have nothing. It is a 0 pair. 37. These are kind of flying by. Miss Jacobs has $15 to spend on coffee and donuts. She buys 1 coffee for $2.59. The cost for each donut is $1.09. So that's a rate. So automatically I know she has $2.59 plus $1.09x. And she has $15 to spend. So it could be equal to or less than $15. That's how much it has to be. All right, so which inequality can help her find the greatest number of donuts? So I'm looking for which one has these two terms, $2.59 and $1.09x, right here. And notice I had to make sure the symbol was also the same because B was our distractor, where it had the right terms, but the symbol was backwards. All right, and let's go to the last one, 38. Maggie owns a dog grooming business. The price for 2 services are below $31.50 and $17 for a nail trim. The customer receives an 18% discount, so that's important. 18% off, which is the same as doing, let's see, 100 minus 18 would be 82% of the cost. All right, so a customer receives a discount of 18% when he pays for both the wash and trim. What is the total price the customer will pay with the discount? Okay, so I'm going to take, since we know it is 82% of the total cost. So I'm going to rewrite that 82 times 31.50 plus $17. So we're going to add those two together and we get 48.50. Times that by 82. And you get 39.77. All right, so that's it for multiple choice. Hit pause and jot this down. And these were all the multiple choice problems. In a moment, we're just going to go right into constructive response, where again, you have to have complete work and a correct answer. Okay, we're going to jump into the constructive response questions. The first three are 1 point. But what I'm going to do for, especially for people who are in New York, the test is now on computer. So we're going to use the sample page. I'm going to put this link in the description. And here you can get an idea of what the equation editor looks like. So I'm going to hit Math, Grade 7, because I want the Grade 7 one, and hit on the bottom Equation Editor. Make sure you have those three things for whatever grade you're in, and hit Start Test. This is not an actual test. You can X this out and just hit Start, but it has the two boxes. And the top box is for any 2 or 3 point question where you have to show work. You would put it in there. And for the 1 point questions, you're only going to see the bottom box, which is just to put in your final answer. Now, my setup is I have a touch screen and I also have a keyboard. So this is helpful. I do have a stylus, a pencil. So if I wanted to, I could hit this little pencil part and I can draw something with my pencil and hit add and it would be there. So I could do that. But I also want to have the tablet because there are times when I need to write an answer or explain something. So I wanted to have a keyboard as well. But you're going to see me do this in real time. I want you to see what it's like. And just like you guys, yeah, sometimes it's a little bit of a struggle. I had to figure out this platform because I might really know the math, but when I didn't know how to use this platform, I found I made silly mistakes. I got frustrated more easily. And like I always say, when our emotions go up and we can't control our emotions because we're super nervous or super scared, we're more likely to make mistakes because your brain is now in survival mode and not in logical thinking mode. So we want to make sure we know this platform so we're feeling more confident and less nervous, because when we're not confident, we're going to make silly mistakes. Okay, so with that said, we're going to jump into our 1 point problems first. 39 is a 1 credit, so I just have to give the answer, and the answer is 16. So I'll show you how I work through it. The number below shows the proportional relationship between cups of flour and the number of cookies. So if you are doing this on a computer, you couldn't actually do this highlight. You could do some of the highlighting on the computer, but you'd have to solve on paper and then put your answer in. So based on this relationship, how many cookies can be made per cups of flour? So I want the number of cookies per cups of flour. They're telling me that this entire table shows a proportional relationship, so I'm just going to pick 2 of them to confirm. Just going to randomly pick 2. And in the first one, I have 24 over 1.5. So let's rewrite that as 24 over 1 divided by, let's change that to a mixed number already. 2 times 1 plus 1 is 3. 3 halves. And now I'm just going to rewrite that as 24 over 1 times 2/3. And I get 48 over 3, which is equal to 16. Now, here you do get you are able to use, let me move this over. Notice down here, I'm moving it over so you can see it. There is a calculator here. It's the same calculator I've been using in this entire video. So if you weren't sure, you can do 48 divided by 3, and you get 16. Okay, so the only answer I need to put down here is 16 cookies. That's it. It is a 1-point question. I don't have to show my work. I do want to validate and just make sure, so I'm going to pick one more. 72 divided by 4.5, which is the same thing as 72 over 1, divided by 4 times 2 plus 1, which is 9, 9 halves. 72 over 1 times 2 over 9. So that's 144 divided by 9. I'll take my calculator again. 144 divided by 9 is equal to 16. So 16 cookies, that's it. Okay, so for the 1-point question, super easy because all I have to put in is the answer. I don't have to show the work. We'll go to question 40. I'm just going to erase my answer here. Casey and Andrew each went for a walk once a day for 4 days. Casey walks 3/4 miles, Andrew walks 3/5 miles. So let's highlight that. At the end of the 4 days, how much farther in miles had Casey walked than Andrew? Okay, so let's go through this one. So I'm going to start by taking Casey's 3/4, whoops. And she walked that for 4 days. So that's 12 over 4, which is equal to 3 miles. And Andrew walked 3/5 times 4 over 1, which is equal to 12 over 5, which is equal to 2 and 2/5 miles. And I want to know which was more. So 3 minus 2 and 2/5. So I'm going to just change this over here to 2 and 5 over 5. Why? It's like breaking a dollar. I just want to be able to subtract. And I get 3/5 miles. I like changing things into decimals, so I just did 3 divided by 5 to get 0.6. Either one of these answers is fine. So in my part here on the side, I could write 0.6 miles. Or if I want to do it as a fraction, I need to find the bar that is a fraction, this one here. And I have to tap in that top for the numerator, put the 3, and tap here on the bottom to put the 5. Okay, so that's the difference. Either one will work, either one is correct, but I just want you to be able to see how I find those buttons. And yes, I'd have to tap inside to put in my numerator and denominator. All right, so check that with your work. And again, these are 1-point questions, so they're just looking for that answer for full credit. Let's go to 41, and you can see the answer. There are 2 possible answers, 8y plus 5 or 5 plus 8y. It's just a simplified one. So we need to write the expression as the sum of 2 unlike terms. All right, so I have 1.5 times 18y minus 2y plus 10. So I'm going to start multiplying and just distributing, and I get 18 over 2y minus 2 over 2y. So I'm just multiplying, plus 10 over 2. Okay, now if you want to know how I did that, I just imagined in my mind these are all fractions over 1. So that's why I knew it was going to be 18 over 2, 2 over 2, and 10 over 2. Now I can actually do some, let's see, can I do any combining of the like terms? Let's simplify these. So here I have 18 divided by 2, which is 9y, minus 2 over 2 is just 1y, plus 10 over 2, which is 5. And that simplifies to 8y plus 5. And because it could be equivalent, you could have had them either way. So here I just would have had to now type 8y plus 5 or 5 plus 8y. And that's it. That's the final one. So our 1-point problems, super easy, not very complicated because we're just writing a complete answer. So hit pause, jot this one down, and we're going to jump into our 2-point problem. Here's our first 2-point problem, and our final answer is 22 seconds, or t equals 22 seconds. That's very easy to type into that answer box, but there's more going on in this problem, so let's jump in. Here we have a student programs a robot to travel at a constant speed across the classroom floor. The table below represents the relationship between the distance in feet and the robot travels over a period of time in seconds, so distance and time. Write an equation that represents the distance in feet that the robot travels in t seconds. So that's the first thing they're going to look for, that equation. And then they want to see how we use the equation to find how many seconds it will take to go 11 feet. So I'm going to use, since this is a proportional relationship, the form is going to be y equals kx. I'm going to have an equation that looks like this. Now our y in this case is going to be the distance in feet. Our k is going to be the rate, which is distance compared to time. Or let's actually put it in our feet per second. And our x is time in seconds. Okay, so I'm just giving you some of that background stuff. That does not mean that all this goes into your show your work, although you could put it in there. So for me to write this equation, y equals kx, the first thing we need to figure out is what the k is. What is the rate? So we know our rate is equal to y over x. So I'm going to choose a pair. I'm going to choose this one over here. The coordinate pair 2 and 11. So y is 1, x is 2. So our rate is 1/2 feet per second. Now this entire table is proportional, so any of these will work and simplify that. Like for example, if you had chose these two, you would have gotten 10 over 5, which also simplifies to 1/2 feet per second. So that's our k. So here's my equation. Y is equal to 1/2 x. Equation done. Now we need to figure out, use the equation, how many seconds will it take? So what is x going to be when you go 11 feet? Okay, so our 11 goes where the y is equal to 1/2 x. I'm going to divide both sides by 1/2. So on this side I have x, and on this side I have 11 divided by 1/2, which I'm going to put down as a decimal 0.5. Take out my calculator. 11 divided by 0.5 is 22. So 22 is equal to x. So if you're doing this on a paper test, you just have all this written on the paper, your work is shown. However, if you are doing this on the computer, we need to transfer this over to show our work. And I'm going to pretend I don't have a stylus, because I know most kids are not using an Apple Pencil. They're not using a stylus to take this test. If your school has it, fantastic, but many people don't. So I want to make sure I'm helping as many people as possible. So I'm going to start by writing my equation. I don't want to capitalize. I wanted to have a small y. And it's okay if it's capitalized, it just bugged me. Y equals kx. And I'm going to put, because I like the k, k is equal to, and I'm going to use my fraction, I'm going to tap it, y over x, which is the same as, now again, what am I looking to carry over? I want to use what we put here, the 1/2. 1/2 feet per second. Okay, and I'm just going to go to the next line. So now I'm going to go back to my equation and put y is equal to 1/2. Actually, I want it in there. You can see, yeah, I kind of struggle with writing this down. So y is equal to 1/2 x. So I have that written down. So notice I've jotted down this. I've jotted down this. And now I have to show this work. So 11 is equal to, you have to scroll it up, 1/2 x. And we're going to solve for here. And this is where, again, all I'm doing is showing in my work. So 11 is equal to 1/2 x. And I'm going to divide. Notice in my work, I divided both of them by 1/2. So I'm going to do 11, and I'm going to use my division symbol, divided by 1/2. And can you see why so many kids get frustrated with this? Is equal to, I'm doing the same thing, 1/2 divided by, let's actually do 1/2 x divided by 1/2. And I hope this platform gets a little easier to use. All right, so we have that 11 divided by 1/2 is equal to 1/2 x divided by 1/2. So that's the same thing that I've just written here. It just looks different on a computer. That's why I wanted you guys to see this, because I wanted you to really see it. And now I'm just putting in my answer, since we already know 11 divided by 1/2 is equal to 22. So I'm going to put 22 is equal to x. And that's it. So here's all my work. I have it all here, and I'm getting to that final answer. So I have complete work, and I put it here. Now, if you have it on paper, you just hand it all in, and you can see your entire thought process. But if you're doing a computer-based test, you can't just take a picture of your work. You could try to draw it. So I will say that, like, there is a possibility, let me make this a little bigger on this side, where you could, if you have a stylus, had just done y equals kx, y is equal to 1/2 x, and then here we're going to sub 11 is equal to 1/2 x, and then you could just divide so they can see it. And hold on, get the eraser kind of going here. And then you can have 22 is equal to x. And you would just hit add drawing, and it would be here in your work. So that's another way. But there you have it. That's what it completely looks like. So hit pause and jot down this 2-point question into your work. 43 is the next 2-point answer question. The answer would be just 5 guests. So that's easy enough to type. 5 guests in the final answer part. And let's jump in and figure out what work we would have to put in that first section. So Diane is planning a party at a trampoline park. It will cost $55 to rent the park, plus an additional $8 per guest. Automatically, you're guessing this is a rate. And this is our initial cost, that one-time fee. And she wants to spend less than $100 on the party, so it's an inequality. So automatically, I know I have 55 plus 8G for her guest, or 8X, whichever it is. And whatever that is, it has to be less than or equal to, actually it says she wants to spend less than, so not even equal to, she has to be less than $100. Okay, so that's the way we're going to write it out here. Write and solve an inequality to determine the number of guests G, so we have to use the G. If you had an X is okay, but we're going to use G. That she can invite to spend less than $100. So here we go. We have our inequality, so that's the first thing I'm going to write. 55 plus 8G is, and I'm going to use that symbol, less than 100. And now we just have to solve this out. So I'm going to subtract 55 from both sides. And that leaves me with 8G is less than 45. And then I'm going to divide both sides by 8. So 8 has to be less than, and if you use your calculator, 45 divided by 8 is equal to 5.65. So at most 5 guests at most. Okay? All right, so here we have it. We have this all written down. So how do we express that here in our work? So again, pretend you don't have a stylus, and I'll do it if I have a stylus afterwards. So the first thing I did was what? I subtracted 55. So I'm going to do that. I'm going to actually put this in parentheses. 55 minus 55 plus 8g less than 100 minus 55. Okay? So I'll even put it in parentheses just so we can see the work. And that simplifies to 8g is less than 45. Okay, now what am I going to do? I'm going to divide both by 8. So let's write it this way. Let's try this. 8g divided by 8 is less than 45 divided by 8. Okay, so this one kind of looks pretty good. And that's going to leave me with g is less than, and we had this number 5.6. Let me just check that again if I wrote that right. 45 divided by 8, 6.25. I forgot the 2 here. I want to make sure I don't leave any silly little errors. So here we go. G is less than 5.625. So I'm going to put down the sentence. Diana can have at most 5 guests. Boom. There we have it. So this wasn't too bad. This one really wasn't too bad. I liked putting parentheses around the thing where I'm subtracting so that I can see where it is and I know those are going to be a 0. And I did that to both sides. It simplifies. And then when I divided by 8, I decided this time to try using the fraction bar, and it actually came out looking pretty good. And then I have my G, which still bugs me. I don't like it when I know it's weird. I get it. But I don't like the G being capital. Oh, what did I do? There we go. I know it's weird. I just didn't like the G being capital. So G is less than 5.625. And then I wrote a sentence. Diana can have at most 5 guests. And I could even go further. If she has more than 5 guests, she will spend more than $100. So if you are just typing, here you go, that's what it will look like. Now, if you had a stylus, then you would just, again, you would literally just type in that entire part. 55 plus 8g is less than 100. And this makes it easier to show. Look at how fast I could do it this way. And g is less than 5.625. 5 guests. And then I would hit add drawing, and boom, you would have it. So if you're able to draw it with a stylus, or if your finger is faster, it's slow if you use your finger, but if you have a stylus, it's pretty fast. All right, so hit pause and jot this down into your work. Try it out with the equation editor. Literally try practicing this. Do not wait for the day of the test to practice using this equation editor because you're going to find some frustration. Let's look at number 44. It is a probability problem. A student tosses a fair coin with heads H on one side and tails T on the other, and rolls a fair number cube with numbers 1 through 6. So you have a cube with 6 sides, and you have a coin, And notice they're saying fair, meaning that's just telling us that they have all equal possibilities, equal outcomes. How many different outcomes are possible? And be sure to provide the sample space. Okay, so I have to show all the different combinations. Now, we talked about this before. We have a coin and we have a die, a six-sided die. So because I know there are 2 outcomes for the coins times 6 outcomes for the die, I know automatically there are going to be 12 outcomes. But they also want us to show in the sample space all the possible outcomes. So that's why I can't just leave my answer like this at 12 outcomes. So I have to show it, and I can use a T diagram. I can do a diagram so I can have the die, and here's my start. And the first thing that could happen is I get heads and tails. And then I know that I could have a 1, 2, 3, 4, 5, 6. If I do heads, and the same thing, 1, 2, 3, 4, 5, 6. If I do tails, and I can see all the possibilities here. So I could have H1, H2, H3, H4, H5, H6, tails 1, tails 2, tails 3, tails 4, tails 5, or tails 6. The other thing I could have done is just done a matrix. And here's the problem with this. If you do this on paper, really helpful. For my coin, I could either have a 1 or a 2. Sorry, heads or tails. And then I can have 1, 2, 3, 4, 5, 6. And then inside I will just put H1, tails 1, H2, tails 2, H3, tails 3, H4, tails 4, H5, tails 5, H6, tails 6. And each one I can see I have 12 outcomes. So I can just type in here, there are 12 outcomes. With a coin, heads or tails, and a 6-sided die. 1, 2, 3, 4, 5, 6. Done. So I have to put that in there. So here's a super crazy challenge. How do I show this work in here? And this is where I can see a lot of kids deciding, I'm going to skip it. I don't want the extra point. I would use for this, you could type in H1, H2, H3, H4, H5, H6, tails 1, tails 2, because they just want to see how you got all the outcomes. Total outcomes. So you could do that. Or if you wanted to, you can literally have drawn the heads, tails, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or you could have drawn the matrix out for them. So either of these ways will work. I'm gonna just open this up a little bit. So either of these ways can work to just show how you got all 12. That's all they're looking for. So and then you would just again add the drawing so they would have it there. So you can either write it out or draw it out. The first time I looked at this, I was really annoyed because I was like, how am I going to draw out all these problems? But there you have it. So I'm going to move on to the next one, which is 45. So I had to, because I'm practicing writing this out so I can be used to how long it takes, be used to the type of thinking. I'm always doing the work on paper and trying to figure out what's the most important thing I need to put here that shows I know how to do the problem. That's what you're thinking of when you're doing this. So there's a lot of thinking work involved. Here's 45. It's a geometry problem with scale. We have a scale drawing. I know my answer is going to be 588 feet. So I had to figure out how to show my work in this. A scale drawing of a floor. Here's a diagram. 1 inch is equal to 14 feet. What is the area of the actual classroom? So I know that 1 inch is 14 feet. So I'm just going to multiply both of these by 14. So 2 times 14 is 28. 1.5 times 14. I'm not doing that in my head. I'm just not. 1.5 times 14 is equal to 21. And then for the area, I'm doing 28 times 21. And you'll get 588. So this one's not too bad, but I need to be able to show where I got these numbers from. So I'm going to write down the scale is equal to 1 inch. Scale is 1 inch is, so that shouldn't be of, is 14 feet. So 2 inches is 28 feet, and I'm just going to put it y. 2 times 14 equals 28. And 1.5 inches is 21 feet. And y, here we go, I could just put 1.5 times 14 is equal to 21. So I have that. Area is equal to length times width. Okay, so area is equal to 28 times 21. Area is equal to 588. Done. That's all I had to do. So notice I wrote the scale and then I wrote my 2 dimensions. So 2 inches, 1.5, and I just wrote down what it was, and then I used that to find the area. Finish. So hit pause and jot this one down into your notes. Make any corrections if need be. But notice again, for showing my work, I just had to show that I knew how to make the scale and how to change those numbers up. That was the goal. And then to use that to find the area. 2 more 2-point questions to go. Here's the first one. The scuba diver dives 24 feet below the surface. The diver then rises 10 feet, stops, and then goes downwards another 18 feet. How far does the diver need to rise up to get to the water surface? So, all right, let's just think about what this looks like. So at first, when I started doing this, I started thinking of, here's the water, and he went down 24 feet. So I can represent this as he went minus 24, and then he went up 10 feet. So plus 10. And then he went down another 18 feet. So where is he? So when I thought about those numbers, I was like, all right, so he was at 24, he was down 24 and he went up 10, so he was still down 14 feet. And then he went down another 18 feet, so now he is at negative 32 feet. So if he wants to go, so this is where he is. So he would have to swim up 32 feet. So that's my little drawing. I don't want to draw all that. I really don't. So if I'm doing this on paper, I can leave this and have my answer. The diver needs to swim up 32 feet because he is 32 feet below the surface. Drawing all this is going to be a lot. So I do want to write this sentence down. So I would just type in, the diver needs to swim up 32 feet because he is 32 feet below the surface. Okay, so but how would I write this down? So I would actually take this and I would go, all right, so he went down 24 feet up 10 feet and down 18 feet. So I drew it in arrows. I'm just writing as a sentence. And now I would write that down as minus 24 plus 10 minus 18. And then I'm going from left to right, and I would have minus 14 minus 18. So he's at negative 32 feet. The diver is at negative 32 feet, or 32 feet below the surface. And that's it. This is enough work for me to show where he is and what those numbers are, and I can see how I got them and where I started with. But here we go. So I took the information, I expressed it as integers, I simplified it to get to negative 32 feet, and I put that into context to say if he's at negative 32 feet, he has to swim up 32 feet. So that's it. So again, this is hard thinking work to figure out what do I really need to put into these boxes. And that's the math work. So I don't need the drawing. The drawing helps me, but I needed to put this into my work. And then I needed to explain what that 32 means. I had to put it into context and then answer the question. So jot this one down. You can pause if you need to. Okay, so I need to just delete everything here. So I'm just going to quickly delete and go to the next section. It is the last 2-point question, and the answer is 16 rides. So here we go. Alrighty then. A family of 2 adults and 2 children go to the fair. The cost, let's put that in. So 2 adults, 2 kids. The cost is below, so it's $11 admission for each adult, $5 for each kid, and $1.25 per ride. So that's our rates, and these are constants. So I can write $11 for each adult, plus $5 for each kid, plus $1.25 per ride. So I have that so far. And they spend a total of $52. So all that is equal to 52. How many rides did the family pay for? Well, I know there were 2 adults, so 11 times 2. And there were 2 kids, so 5 times 2. Plus $1.25x is equal to 52. So 22 plus 10 plus $1.25x, or 32 plus $1.25x is equal to 52. All right, now I'm going to use my zero pair. I'm going to subtract 32. And that's going to, oops, I'm not making a zero pair there. So that leaves me with 20. $1.25x is equal to 20. Divide both of these by $1.25. And you get x is equal to 16. Let's triple check that. 20 divided by 1.25. Yep, is equal to 16. Okay, so I can write this down. They went on 16 rides. That's the first point. Now I got to put in all the work. So I'm going to write my 11a plus 5k plus 1.25x is equal to 52. And now all I'm doing is recopying, and I will say this gets easier the more you practice with it. Look at how fluent I am now, and I'm doing this with one hand because I have the mic in the other hand. I have to use my microphone this way, but all I'm doing is copying it in. And now here was the part where, how do we show the subtraction in zero pairs? So I'm going to use my parentheses. 32 minus 32 plus 1.25x is equal to 52 minus 32. And now I get 1.25x is equal to 20. And now I'm going to, let's see how this looks. 1.25 divided by 1.25x is equal to, I'm going to do the same thing on the other side, 20 divided by 1.25. So yeah, that actually looks pretty good. So I'm going to be left with x, I want the little x, is equal to 16 rides. Done. This was not too bad at all. So there we have it. I have my original equation. I substituted. I combined like terms. I got rid of the 32 to isolate the variable. I made a zero pair. I then divided by 125, so I just get the x by itself, and x is equal to 16 rides. So there you have it. You can, here, I'll make this a little bigger for you so you can see all of it. Here you go. So you can jot this one down into your notes, and we'll go to the very last problem, the last 3-point problem. So here we are at the very final problem. You had to explain how you determine your answer here. So here we have an airline question, and the answer is airline A is a better deal. Airline A costs less than B. So that's an answer, but doesn't explain how I got my answer. So I'm going to have to put all that into my answer box. So let's figure out why. This is an RP question. Airline A and B offer discounts to the same destination. The original ticket are described below. Airline A gives a discount of 25% off the original price of $150. B is 1/3 of the original price of $180. Which airline offers the least expensive ticket? Be sure to include the discounted ticket price in your answer. So you see right there, because if I would have just wrote this sentence and not written what the discounted price is for both airlines, for each of them, then I would not get full credit. So that's going to be important. So let's show how I find A and B. So A is equal to 25% off $150. So 25% off is the same thing as 75% of 150. We know how to do that. It's 0.75 times 150. You'll take out your calculator. 0.75 times 150. So A is equal to $112.50. B is a discount of 1/3 off $180. So 1/3 off means that it's 2/3 of $180. So how am I doing that? I'm imagining this is the whole thing. If I take 1/3 out, I'm still left with 2/3. Okay, so I'm going to do 2/3 times 180, which is 360 divided by 3, which is $120. So A is the better deal because $112.50 is less than $120. So all of that has to be my answer. If this was on paper, I'd have to write that sentence down. A costs $112.50, which is less than B, $120. So that's how I would stop if I was on paper and I can see my work, I can see the explanation. Now, because if you were doing this on a computer-based test, I have to write all that out. Airline A is their better deal because airline A costs $112.50 and airline B costs $120. So and then if I really want to get fancy, $112.50 is less than, oops, wrong place, less than $120. And that's it. and I can stop there. Now, if to show my work, because I want to be able to show where I'm getting all this from, I want to make sure that it's super clear where it's coming from, I can put A is equal to 25% off 150 or 75% of 150. Excuse me. A is equal to 0.75 times 150. A is equal to 112.50. And that's all I will put. And then for B, I would put B is equal to 1/3 off 180. Let's put in those dollar signs just so that so everything is there. Okay. Or 2/3 of 180. B is equal to, nope, I do not want that. I wanted this one here. 2/3 times 180 over 1, which is equal to 360 over 3, which is equal to 120. Boom. And then I would just put B is equal to $120. And that's done. That's it. This is all I would need to show my work. I showed how I got A. I showed how I got B. I can see it there, and I wrote it in a clear sentence. Airline A is better deal because airline A costs 112, airline B costs 120, and $112 is less than 120. And that's it. That is the complete 7th grade exam, parts 1 and part 2. All the multiple choice points are worth 1, and all the constructive response, they're either worth 1, 2, or 3 points. And I will put into the comments what score you would need in order to get a level 1, a 2, a 3, or a 4. I have to actually look that up, and once I find those answers, I'll put them into the description. All right, so that's it for today, Math Marbles. This was a sample practice test for the 2024 state exam using mostly 2023 questions. I hope you found it helpful. If you're doing it on paper, you can see everything here. And if you're doing it on the computer, I will link the equation editor so you can get some practice. I know you have this, Math Marbles. Good luck. And if there are any topics that you would like to see me do in a short or in a YouTube video, please let me know in the comments and I'll get that ready for you. That's it for now, Math Marbles. Take care.